example, check if the first 4 bytes are equals to quest. Otherwise, the packet is rejected. So it's quite useless to do that. You are wasting your time. If you know that it starts with quest and end with the string end, another check function check if the length of the string is equal to the length value. Otherwise, the packet is rejected. Trying to test the strings is completely useless. If you know exactly how is the protocol, you have chances to reach vulnerable functions. This case is inspired by a remote administration software, and the flow still exists. I like to speak with cryptographic problems. So in this case, if you have only 15 bytes, trying all the solutions is like trying an exhaustive search on a key of 120 bytes. If you know how the protocol works, it's only 4 billion solutions to try, only. So the advantages of this technique is you don't need the source code. Sometimes you even don't need the binary. Every uncovered buffer overflows are real. You don't really need skills to do that. You can let the computer doing the work at night. The drawbacks are a lot of tests are useless. And as the binary file analysis, it takes a lot of times. And of course, it's not a total solution to discover every buffer overflows. So a proposition to increase the efficiency of this technique is to reduce the test space. To do that, we have seen through the example that if you understand the protocol, it's much more better. If you especially can parse length, it's better again. And finally, every substituted strings are not relevant. First, understand protocol. In this case, if you know that the protocol is written like this, you can reduce significantly the test space. If you can parse length, it's very important. In this case, the length value should correspond to the length of the string value. And finally, testing some strings are useless. For example, if you test these strings and again these strings, there is chances that it will give the same answer. So if you can reduce the size of the fuzzing library, it's much more better. But these techniques represent the state of the art of fuzzings. The problem is in practice, the size of the test space is still near infinite. So the idea is to reduce it again. This solution called fuzzing by weighting attacks has the same objective. So what is the size of the test space? First, we have what we call a fuzzing string library. It's in fact a space which contains all the substituted strings you will test. For example, a lot of A's, a lot of B, etc. Then you multiply the cardinality of this space with the number of strings you want to fuzz. In our example, it's quite simple because we have only one string to fuzz, but in most of the cases, you have a multiple choice of strings. Then you can add another space which corresponds to the number. Fuzzing number is quite important too. So this equation represents the size of the test space. If we want to reduce this size, we know that we cannot really try to reduce the fuzzing string library because normally every field in this library has been chosen because one time a buffer overflow has been discovered by these kind of things. Remember format strings, trying these kind of things. The same thing for the fuzzing number library, but this one and this one can be reduced. And it's a multiplication here, L times S. So it's much, much better to reduce these two subspace. How to do that? For example, by using weights, weighting the attacks. We have a fuzzer and a target. This target is monitored by a tracer debugger. In this case, imagine you send an original packet dumped with a sniffer or whatever. If this tracer is able to say, no, don't fuzz this packet, it's useless to try this one, at least at the beginning. He sends another packet, and then the tracer say, okay, I found something interesting, like a format string, try to fuzz it. Then the fuzzer will try every entries of the fuzzing library and eventually find something. That's what I said. We reduce these two spaces. Okay, it's fine in theory, but how to know if it's relevant to fuzz or not to fuzz a string or a value? Using markers can be a solution. So the question is, what is a marker? In this case, a marker is a string, like this one, and this one. As we have seen, this one can be relevant to fuzz, but not this one and this one, because they are fixed string just used by the protocol. The idea is quite simple. The tracer first say, okay. The fuzzer say, okay, here is the string I want to try to fuzz. He sends a normal request. Then the debugger can analyze how the target software works. And he can say, okay, what I have seen, this string is used by strcpy, so it's relevant to try this string at the beginning. Then the fuzzer knows which string he has to try first, and in this case, find a buffer overflow. So there is 4 steps. The first one, understand known and, why not, unknown protocols. Length parsing, fuzzing, using a fuzzing library, and finally, weighting attacks with markers. Autodafe is an implementation, practical implementation of this technique in order to prove the efficiency. Autodafe comes from his act of faith. In fact, it was used during the Inquisition, especially in Spain. The idea was to burn somebody, and if the smoke is white, it was good, and if it was black, it was not good. But it's too late. So the idea is to torture software, so that's why the name is chosen like that. Autodafe is used by 4 modules: ADC, PDML2AD, Autodafe, and ADBG. The first one is to answer to the question, understand known and unknown protocols. It uses a block-based script language. In fact, it's very close to the block-based script invented by Dave Aitel through the fuzzer Spike. Here you have a parser which can check your syntax. It's much more for development. It can check your syntax and be sure that your file is correctly done, and there is no error. Here is an example of the description of the example. Remember, it's this string. You have quests, a number, a string, and another string. So you define first a packet, a block. This block starts here and stopped here. First, you have a string, fixed string. Then you define a value, size value. In this case, big endian 32 bits. And you give the name of the block. Then, if you change this value or any value on the block, the size will be recomputed and accepted by the check functions. Then there is another string, this one. And finally, the string end. And at the end, you have just a carriage U-turn. You finish the block here, and you send it. By default, it's sent by TCP. The biggest problem if you have used fuzzers like Spike is to write your own script and try to understand how protocols works. So the idea is to use the Ethereal engine to recognize 530 protocols. To do that, you just need to export a dump using the PDML function, and then convert this file using this tool. This, you can just dump a SendMail connection, SMTP connection, for example, and after that, just choose what you want to try to fuzz, which field you want to try to fuzz. This is an example of the automated recognition on our SSH communication. The first packet, you see you have some commands, the string, and the order if it's a received packet or a sent packet. For the fuzzing library, the idea is quite simple. You have a file, and on this file, a file describes other files. On every file, you have the letter you want to substitute to every strings. The idea is to test server-side and client-side, because in practice, most of the time, every server are well tested, but clients not all the time. For example, CVS or Subversion are not very well protected on the client side. You can fuzz files. Now it's quite well used, but the idea is to not create connections, but create a lot of files and test each file recursively. The fuzzer, called Autodafe, this is this part here, can be connected to a debugger in order to wait attacks. As I said, the fuzzer can automatically recompute the length fields of each first packet. Here is an example of the size you can give: 32-bit, little, big endian, 16-bit, 8-bit, or even strings using characters. For example, when you send an information using HTTP post, you need to write the content length field with characters. ADBG is in fact a debugger. It's connected to the engine fuzzer Autodafe, and they work together. They communicate using a TCP connection. This software exists on Windows and Unix. The idea is the fuzzer sends first the marker to the debugger, then the fuzzer will send an original traffic in order to analyze the behavior of the target software. Finally, the debugger tracer will listen on every vulnerable function and send reports to the fuzzer and give weights which one he has to try first. To conclusion, what I wanted to say is about Alan Turing. He said that it's not possible in this paper because he considered these machines as mathematical abstracts, fictions. But in practice, this difference can be used by people to change the behavior of a computer. There is a small story about the Apple logo and Alan Turing. I've read on the booklet of the 223 that Steve Jobs said that the logo comes because he was working in an Apple company who sell apples. Another story is to say this is a tribute to Alan Turing, because even if he's, for me at least, the creator of computers, he was rejected by the English community because he was homosexual, and he committed suicide 50 years ago by eating an apple he laced with cyanide. So you can see the homosexual flag with 6 colors and an apple half eaten. Before the question, I will show you 2 examples. One with it's just a school case. It's the same protocol we have seen. And another example, a real case on file.